Right, before we go across to GerberMill, I'd like to just look at how we need to supply a Gerber file to GerberMill. We'll start by looking at real PCB. If we open a file up, let's start by going and finding one of the Burt robot files, which I know is done in real PCB. Right, so we're loading the program up, and there's a couple of things that I want to do before we actually send this out, and it's purely down to a matter of choice. But the thing that we must do is we must initially remove the border. If you want to leave the writing, that's entirely up to you, but the machine can struggle sometimes with the writing, partly because the gaps between the letters are so small, it's impossible to get a tool in there. We will leave it on just to prove that it won't stop the whole process, but some of the small writing will struggle to be produced. Okay, so we've got this file there. Now then, we take that and go over to the tools section, CAD/CAM outputs, and initially we want to output this as a Gerber file. Okay, so what's ticked there is quite adequate. It will do everything we need for us, and we'll say OK to that, and it will say output files have been generated, and say OK. We'll go back into the CAD/CAM and we will output an NC drill file. Reason we're doing that is that in the options on the NC drill file, because PCB has this as an option, we definitely need to tick include tool sizes in the output and remove duplicate holes. The remove duplicate holes will do nothing more than save you damaging drills. If a drill comes down slightly out of position, they are prone to break. They don't like being bent. They're a very small drill at 0.8 millimeters, the usual size that most people drill the holes at. And if you don't include the tool sizes, the system will struggle to understand the file. As you can appreciate, drill files work to a format. Unfortunately, the format has never really been finally agreed, and we're stuck with it as it is for now, and almost forever, because of the way things move on. So we'll say OK to that. It'll say output NC drill file. It was OK. So remember that we've done motor new 03. And we'll go outside. We'll close down the real PCB. I won't save the changes because when I bring that back up, I'd like to have the border there again, purely just so as I know how big the PCB in use is going to be. Right, and while we're there, we'll take a look at Circuit Wizard, which also includes PCB Wizard. So if we're using Circuit Wizard, then or PCB Wizard, they both use the same tool, one being a subset of the other. We'll open up a Wizard program, which this is one that's working. It was a work in progress of the weather station. It isn't quite finished yet. There's one or two bits and bats need adding yet, and what we'll do is we'll go down the route in Circuit Wizard of going to the CAD/CAM option. We'll go to the Export Gerber, which I do click them all. In reality, GB1 is the one we're looking for, which is the solder side, but I like to have all the others there in case I want to do some other artwork or drop things on websites. Say OK to that, and that's gone through and done that, and then we'll go back to the CAD/CAM and we'll export an NC drill file at the same time and say OK to that. So the PCB Wizard doesn't really need any of the options altered. As it sends it, the GerberMill will access it without any problems. Right, so we've loaded the software up and selected a milling machine, and we'll go over now and import to the Gerber file. That gives us the Gerber mill. This gives us the start out program. Now I'm very quickly going to go in and just show you one of the capabilities of the system. What I will do is very quickly load one layer. I'll go and then load a second layer. Unfortunately this is a little bit of a distance off, but it's actually there. So, oh, and that's worth pointing out as well, if you are loading from PCB Wizard, you load the GB1 file. And one of the nice things it shows us is that the GB1 file is much bigger than the board we've allowed for, and if we say OK, it will automatically resize the board. And then we will add a drill file, and when we try to move on, the first thing it tells us is that all the holes don't match, which is no surprise considering the two totally different projects, but it is a nice little reminder that if you have made a mistake, or if the boards aren't orientated properly, that it will very quickly notice that there are problems and that you are drilling through onto what is effectively an empty board. Okay, so I'll drop that and relaunch. We'll go back into the Boxford and go back into the Gerber mill. Okay, and resize that. So, the next thing I want to point out is that the machine says select the top layer. In reality, it means as it sees it from a machining point of view. The top layer to it is the first layer that it's going to machine, which on a single side board is the only layer that it will machine. So when it says select top layer, it actually does mean that the layer that is effectively going to be on the opposite side to the components. So if we now go in and actually select that layer and bring up the Bert robot brain, the one thing you'll notice is that if this is actually the top layer, then we're actually looking at it copper side up, that's facing the wrong way. So we need to remove that tick, which allows us to invert the board so that it is actually viewed from the top in machining terms. So what we've got is we've got that board set up now, so that as we look at it, the components will be on the other side. It's a single-sided board, so we don't need to put a bottom layer on. We could go straight on and actually bring in the drill file. Now then, if the drill file doesn't load up and you don't properly, in other words you don't get a green beige with holes in it, then you've got problems there that it can't see the file. You need to actually go and look at the options that you've set to when you've saved the file to be certain that it's the correct way. And of course this needs inverting to match the first one. So if we go back, first one's inverted, no multiple layer, single layer board, and the drill file is inverted. So the next thing it allows us to do is actually alter the board size. Now you notice the next is lit up. If I alter the board size too small, and actually say, well, actually the next switches back off, so you can't actually order or request the machine to build on a board that is smaller than the one you've designed. So if we put that back to 80, I don't like to leave a board around. It's handy for clamping, it's also handy for any additional screw holes that you may want to put in to help secure the board. Most of the rest of the settings I have are quite fine. 2mm thickness overall, and then 0.1 for machining is normally about right for most manufacturers. That's about the thickness of the copper that they use. So we're moving on now, and the last thing I'll do is to actually centre the whole thing. So in other words, if you wanted the whole thing up to one side, you could alter that to 10, and it will go, or alter it to 5, and you can see how that moves it much closer to one edge. The truth is we want this board centering, and the next thing we're going to do is pick the tool. Now then, You must pick the tool that's got the sharpest possible point, and of course the chamfer goes almost down to nothing. So we've found if you use the chamfer, it allows you to make much more complicated programs because it can work into areas that other tools wouldn't even get a look in. We'll leave the offset past at 5. Right, so we're going to process the circuit board. You can remove all the copper, or you can you can select the holes to be pilot drilled, which if you've got big drills it may make sense pilot drilling them first. We'll run the process, and what that does is, having worked its way through, it will put a series of nice little yellow lines around to show you where the machine is going to take effect. Once it says circuit processed, we can now move on and actually save this file so that the system can physically start machining it. So it says save into the GMM system. Now it has come up with 1 or 2 complaints about where I haven't got diameters this, and for the holes that I've drawn, that we are missing drills in the drills library, but at this stage, because we're showing the software, we'll not worry about what the that particular area, because it won't actually stop us carrying on. We'll press continue, and the system then will go through and simulate all your machining. And then of course run through and drill all the holes. Yep, and there we go. That's our finished circuit board, ready to go to manufacture. We now select the machine and go through placing the board on the holder.